You're listening to DTFHN for May 26th, 2026. I'm your load-bearing host, Jack Haxman. We're your daily tech feed for Hacker News. A website where people who mass-deleted their code feel compelled to tell strangers about it. Today's got that restless builder energy, the kind that smells like solder and overconfidence. Let's get into it. During ZIRP, the average big tech company had mass-hired hundreds of engineers with nothing profitable to do. And somebody figured out that if you put one very senior engineer in a room and told them their job was to reject proposals, you could keep the other 200 busy indefinitely. Proposing, getting rejected, reproposing, an entire flywheel of activity that produced nothing. And that was the point. Nobody needed to produce anything. The stock price went up when you hired engineers, not when they shipped code. That's the argument Sean Godecke makes, and it's worth sitting with for a moment, because the uncomfortable question underneath it is one almost nobody in engineering leadership wants to ask out loud. How much of what we called engineering culture was actually just a side effect of free money? The just say, no engineer. The senior or staff engineer whose identity is built around blocking changes, maintaining purity, ensuring as little code ships as possible, had a real function during ZIRP. They were a governor on an engine that was redlining for no reason. Too many engineers, too much freedom, too little alignment with anything resembling revenue. The gatekeeper kept the code base from becoming completely unmanageable while the company burned investor cash on rewrites and tangential open source projects nobody asked for. Now ZIRP is over. Interest rates went up, 20% of the engineers got laid off, and suddenly companies need to ship things that make money. To just say, no engineer is in a genuinely awkward position. Not because AI is generating more code, but because the economic conditions that made their role valuable evaporated. The reader comments push back hard, and some of the pushback lands. If capital is expensive now, shouldn't you be more selective about what you build, not less? Shouldn't the gatekeeper matter more? It's a fair point, but it confuses two different things. Selectivity about what to build is a product decision. Reflexively blocking how things get built is an engineering culture artifact. The just say no engineer was never really doing product strategy. They were maintaining a quality standard that existed, partly because there was no cost pressure to ship faster. The deeper pattern here is that builder culture. People who ship, who iterate, who put working code into the world, always wins when the economic constraints tighten. Free money subsidizes gatekeeping. Expensive money rewards output. The engineers who thrive now are the ones who can say yes intelligently. Yes, but with these trade-offs explicit. Yes, but we're monitoring this. Yes, and here's what we'll fix in the next iteration. The era of getting paid to say no is over. The era of getting paid to ship wisely is just starting. So Cloudflare just mass-launched a fleet of new products. And honestly, some of this is genuinely exciting infrastructure. Buried in the documentation, one line you'd miss if you weren't looking. Flagship uses KV. That's it. Cloudflare's new feature, Flag Service, the whole thing, runs on the same key value store they already sell you for a fraction of a cent per read. The entire product is a convenience layer over infrastructure that already existed at the edge. This matters more than it sounds like it does. Feature flags are one of those tools that every team above a certain size ends up needing, and nobody wants to build. You want to ship a feature to 5% of users on Tuesday. Watch the metrics, then roll it to everyone by Friday. Simple concept. The implementation, historically, has meant either bolting on a third-party service, launch dark restats, split, or maintaining your own janky config system that somebody wrote during a hack week in 2019, and now it's load-bearing infrastructure that nobody understands. Cloudflare looked at this and did the most Cloudflare thing possible. They made it a binding. If you're already running workers, Flag evaluation happens at the edge with 0 network hops. Your feature flag check is as fast as reading from KV, which is to say, it's as fast as reading from memory on the machine that's already handling the request. No round trip to a flag service. No SDK phoning home. The flag value is just there. But here's the detail worth pulling on. They built it on Open Feature. That's the CNCF open standard for feature flag management, which means you can swap Cloudflare out. One line of configuration. The evaluation code stays the same. Cloudflare is betting that if they give you a feature flag service that's faster than anything else because it runs where your code already runs, you won't want to leave. But they're using the open standard that makes leaving trivial. Run this forward 5 years. Every major cloud provider ships their own feature flag service. The ones built on Open Feature let you migrate between them. The ones that don't become another lock-in vector. Cloudflare just made a bet that speed and integration win over switching costs. That's a bet you can only make when your infrastructure advantage is real. One of the commenters noticed something the docs quietly admit. The client-side API token isn't scoped to a single app. Anyone with the token can read all your flags. That's the kind of detail that separates a V1 from a production-ready system. Cloudflare ships fast and iterates. The permissions model will catch up. It always does with them. The real comedy here is that feature flags started as a deployment safety mechanism and became an entire product category with venture funding and sales teams. Cloudflare just made it a checkbox on infrastructure you're already paying for. Sometimes the funniest disruption is the most boring one. Nouveau. In 1769, James Watt patented an improved steam engine, and within a generation, handloom weavers in Lancashire watched their livelihoods evaporate. The weavers didn't smash machines because they feared progress. They smashed machines because the factory owners captured every efficiency gain and left the people who built the textile trade with nothing. The technology was inevitable. The distribution was a choice. We are replaying that script right now, and the author of this piece sees it clearly when Dario Amodei announces that AI will replace entire job categories. When Sam Altman declares college degrees worthless, they are not describing a natural law. They are describing a business plan. The technology is real. The intelligence emerging from next token prediction is genuinely remarkable. But the CEO class is not excited because humanity is about to flourish. They are excited because labor's last bargaining chip, the chip of being needed, is on the table and they intend to take it. The article asks whether the people cheering loudest for this moment are simply the ones with the thickest cushion. That lands. When a venture capitalist in San Francisco says coding is solved, they are standing on a foundation of equity, connections, and capital that makes the disruption feel like a spectator's sport. For a developer in Nairobi or a translator in Manila who bootstrapped their career through sheer skill, solved means something different. It means the ladder got pulled up. And this is where the open source question stops being abstract. If the models are closed, if the weights are locked behind API paywalls, if only the companies that built them get to decide who benefit, then yes, this technology concentrates power exactly the way the article fears. But if the models are open, if the weights are public, if a developer in any country on Earth can run, fine-tune, and build on the same intelligence that Fortune 500 companies use, then the technology becomes the equalizer it should be. The steam engine was never the enemy. The factory gate was. The article's deepest insight is that there is no winning team. The people celebrating today are not immune to what comes next. No one is. The only question that matters is whether the tools stay open, whether the gains flow outward, whether we build the world where intelligence compounds for everyone or gets captured by the few. That is not a technical problem. It is an architectural one. And we are making that decision right now. Architecture decisions matter everywhere, including, it turns out, when you're storing thousands of gallons of industrial chemicals in a residential neighborhood. One commenter, a firefighter, posted this about the Garden Grove methyloswerthax walt methylmethac methylchemontrove. By the miraculous grace of God, a crack allowed pressure to bleed and enabled our engine company to prevent thermal runaway. A believe was the projected outcome. For anyone unfamiliar, a believe, a boiling liquid expanding vapor explosion, is the thing that turns a chemical incident into a catastrophe. The crack in the tank saved the neighborhood. Another commenter asked the question I guarantee every chemist reading was already thinking. When this is all over, when they peel the metal tank away, will they have a gigantic, clear block of material? And the answer is maybe, because what was happening inside that tank is one of the most elegant and terrifying chain reactions in all of chemistry. Derek Lowe's write-up on Science is a masterclass in making polymer chemistry visceral. Here's the mechanism. Methyl methacrylate has a carbon-carbon double bond with an electron withdrawing group on one end. A free radical hits the unsubstituted end, breaks the double bond, and creates a new radical on the other side. That new radical attacks the next molecule, which creates another radical, which attacks the next molecule. Each bond formation releases heat. The heat accelerates the reaction, which releases more heat, which accelerates it further. Bold this to its logical extreme, and you understand exactly why that tank was an emergency. You have a self-amplifying reaction where the product of each step is the catalyst for the next, and the waste heat is accelerant. The only thing standing between a stable storage tank and a runaway polymerization is the inhibitor chemistry. Compounds deliberately added to scavenge free radicals before the chain can propagate. Let the inhibitor degrade. Let the temperature creep up. Let sunlight hit the surface, and the monomer starts doing what it desperately wants to do. Thermodynamically, become plastic. This is the part that deserves real admiration. The chemical industry stores millions of tons of these monomers worldwide, and incidents like Garden Grove are rare precisely because the engineering is meticulous. Temperature monitoring, inhibitor maintenance, material compatibility. Every storage protocol exists because someone understood this chain reaction deeply enough to interrupt it. The knowledge is public. The safety data sheets are public. The post-mortem analyses from previous incidents, tyrant butyl acrylate, are published and freely available. A commenter linked one such post-mortem. Open documentation of failure is how the field learns. Every published incident report is a gift to the next engineer designing a storage system. That is how safety compounds the same way the polymerization does. Each contribution building on the last, if you let people access it. The crack in the tank was luck. Everything that came after was craft. Moving on. There's a principle in acoustic engineering called the inverse square law. Sound intensity drops with the square of the distance from its source. Double the distance, quarter the energy. Network latency works the same way. Roughly, every mile of copper or fiber between you and another player is another millisecond of fiction. You're gum pretending you're in the same space when you're not. A LAN Party eliminated the pretense. You were in the same space, 3 feet of Cat5 cable. sub-millisecond response. The physics were honest. Think of it like the difference between a jam session and a Spotify playlist. A playlist is convenient, frictionless, algorithmically optimized. A jam session is loud, chaotic. Someone keeps knocking over the mic stand, and the bass player brought terrible beer. But the music that comes out of it is alive in a way no stream can replicate, because the feedback loop is immediate. You hear something, you respond. The room shifts. That's what a LAN party was. The feedback loop collapsed to the speed of sound across a living room. The article traces how broadband killed the latency advantage. And that's true as far as it goes. But the real killing blow came from architecture, not infrastructure, always locally online DRM. Games that refused to function without phoning home to a corporate server, even when every player was sitting in the same room. Studios looked at a bunch of kids sharing a physical space with hardware they owned, running software they'd paid for, and decided that was a problem to be solved. This is the pattern. You build something open. A protocol, a gathering, a culture. And somebody eventually decides the openness is a revenue leak. LAN support wasn't deprecated because it was technically obsolete. It was deprecated because it let people play without being observed, tracked, and monetized. The comments tell the real story, though. A firefighter throwing biannual LAN parties. 5,000 people gathering in Norway. Fighting game locals running brackets in every major city. The infrastructure of joy maintained by people who refuse to let the feedback loop get longer. The studios can kill the feature. They can't kill the impulse. People will always want to be in the same room, hearing each other's actual voices, reaching for the same bag of Doritos. The latency on that is zero. And sometimes zero latency means 0 pixels between you and the art. Let's talk about some gorgeous modern pixel fonts. Let me make the case for Vercel's pitch. Pixel fonts are a graveyard of broken deployments. You drop one into production, the vertical metrics are wrong. It conflicts with your type stack. It renders at 13.5 pixels, and suddenly every glyph is a smeared mess. The argument that you need a professionally engineered pixel font with proper metadata, kerning tables, and viewport scaling. That's not pretentious. That's just correct. And then you look at what's actually happening in this space, and the argument collapses under the weight of its own seriousness. Andrew Gleason looked at VCR OSD Mono, a font baked into the visual memory of anyone who programmed a VCR or point to the camcorder at a birthday party. And his diagnosis was precise. The baseline was too low. Descenders on letters like G and Y got pulled up into the body, cramped and awkward, because the original designers were working within the physical constraints of on-screen display hardware. Fixed vertical space. No room to drop below the line. Gleason's analog mono simply fixes that constraint. The descenders descend. The letter forms breathe. It's a correction that took 30 years because nobody thought a VCR font was worth correcting. That's craft. The kind where you notice a 2-pixel problem that millions of people looked past. Then there's Kumiko Yoshida's Coral Pixels, which takes sub-pixel fingering, the red-green-blue color bleeding that was literally a rendering defect on LCD screens, and promotes it to a feature. The artifact becomes the aesthetic. What was once your monitor failing to cleanly address individual subpixels is now nostalgia, baked into the vector outlines as deliberate color. It's the typographic equivalent of vinyl crackle. And Joseph Fatullo's 2-slice is 2 pixels tall, too. Somewhat readable. The audacity alone is worth celebrating. Every one of these fonts is open or freely available, Analog mono, coral pixels on Google Fonts, 2 slice. The common surface more. Departure mono, unsky for terminal use and ASCII art. B2 HDPI for bitmap font scaled to modern displays. One commenter points out that original pixel fonts assume non-square pixels, aspect ratios nobody remembers anymore. The historical constraints shaped the original letter forms in ways we've forgotten we're looking at. Keist pixels engineering is real, but the joy in this space isn't coming from the production-ready system font. It's coming from people who looked at 2 pixels of vertical space and thought, yeah, I can make letters out of that. This one is pure bootstrapism in action. In 2003, I watched a publishing house lose 3 weeks of editorial changes because someone saved over the wrong version of a Word document on a shared drive. The file was called Manuscript Final v3.1.time. 23 years later, most book production still works this way. DJ Spec Hals built something different. A Git-Tracked pipeline using LibreOffice, standard ebooks tooling, and LaTeX that takes a single manuscript source and produces print-ready PDFs, EPUBs, and Kindle formats. Every change versioned, every output reproducible. The kind of infrastructure that software teams adopted decades ago, applied to a field that still treats email the Word doc as a workflow. The technical stack is worth being precise about. LibreOffice handles the initial authoring, which matters because it means writers don't need to learn markup languages to participate. Standard eBooks provides the toolchain for clean semantic EPUB generation, a project that's been quietly building the best open-source book formatting pipeline available. LaTeX handles print typesetting, and Git ties it all together, giving you diffs, branches, history, the entire version control apparatus that publishing has somehow avoided for 40 years. The historical parallel here is almost too clean. In 1991, Linus Torvalds posted a hobby operating system to comp.os.minix because he was frustrated with proprietary licensing. The publishing industry's lock-in to Adobe InDesign and Microsoft Word is the same structural problem. The tools work. They work well enough. But the architecture concentrates control in 2 companies that have no incentive to make your workflow portable or reproducible. InDesign files are opaque binaries. Word's change tracking is a cursed labyrinth. Neither is designed to interoperate with anything. The comments surface something useful. Several people have built similar pipelines using types. ASCII Doctor, Pandoc, Caliber. One commenter runs a nonprofit producing EPUBs, print PDFs, and digital editions from a single source using types and Pandoc. Another points out that commercial print veterans already understood these workflows could be automated. The tools existed. The knowledge was available. What was missing was someone stubborn enough to wire them together and document the result. That's builder culture. Working pipeline beats 100 blog posts about how publishing is broken. We talked earlier about tools reshaping workflows. Now let's watch an entire language reshape how developers think, from Rust to Ruby. What if the best thing you can do with 15,000 lines of code is delete them? A developer had a Rust web app, Axum, Terra, Diesel, 15,000 lines, 10 seconds to compile. A Playwright test suite so convoluted it needed its own internal API crate just to run headless browser tests against a mocked database namespace. This is a web app serving HTML, and the testing infrastructure had metastasized into something that probably needed its own testing infrastructure. Now let me argue the other side for a moment. Rust earned those 15,000 lines honestly. You get memory safety, fearless concurrency, a type system that catches bugs at compile time that Ruby won't catch until production. Every one of those lines is a contract with the compiler. That matters. That's real engineering discipline. Except this person is a solo developer building a web app. They don't need fearless concurrency. They need fearless shipping. The compile times alone were eating their iteration cycles alive, and the test setup had become a second project bolted onto the first. Here's what happened. They pointed a local Quen 3 running on a Fortnite 9D at the Rust code base and asked for a one-shot conversion to Ruby on Rails. 30 minutes later, 3,322 lines of Ruby, down from 14,943. They browsed it, said it looked clean and idiomatic, and then, this is the part that made me laugh, they published a blog post about it without ever running it. The comments are predictably outraged. You didn't even start it, but honestly, the fact that it's plausible tells you something. Rails conventions are so strong that a local 7 billion parameter model can infer the correct structure from the Rust source. Active record replaces diesel. Convention over configuration replaces thousands of lines of explicit routing and serialization. VCR cassettes replace whatever Rube Goldberg test mocking apparatus they built. And the tool that did this runs locally, on hardware this person already owned, with unlimited tokens and zero API costs. No vendor lock-in, no usage meters. A model running on their own GPU, converting their own code on their own term. The real punchline isn't the 77% reduction in lines. It's that Rust's famous safety guarantees were protecting this developer from bugs they were never going to have. At a complexity cost they were always going to pay. Sometimes the most dangerous thing about a bulletproof vest is that it's too heavy to run in. And sometimes the best reunions happen when the pieces finally get light enough to fit back together. 30 years out of college, and the class of '96 can't stop talking about one thing. Not their careers, not their kids' college applications. AI, specifically what large language models are doing to knowledge work, and what that means for the young adults they raise to do knowledge work. Brian Cantrell just came back from his 30th reunion at Brown, and he describes a gathering where every conversation, every single one, circled back to the same dread. Parents who spent decades building expertise in law, medicine, finance, engineering, now watching their children enter a world where that expertise might compound differently than it did for them. He's honest enough to put it in perspective. His mother's class of '68 faced the draft. You want anxiety about the future? Try a lottery number that decides whether you go to Vietnam. But he says 2026 feels singular, and I think he's identifying something real. Here's what's underneath the anxiety: control. These are people who succeeded in systems they understood. You study, you credential, you practice, you advance. The implicit contract was legible. What LLMS introduce isn't just disruption. It's opacity, the systems making decisions about whose knowledge matters and how it gets used are overwhelmingly closed. Proprietary models trained on the collective output of human expertise. Controlled by a handful of companies, with objective functions that can change on a quarterly earnings call. That's not a technical complaint, that's an architectural one. And buried in Cantrell's essay is the antidote, even if he doesn't frame it that way. He spends half the piece describing Battletris, a game he built in a basement in 1993, shared with friends over a no-modem cable, iterated on for years out of pure joy. No business model, no moat, just builders building because the building was the point. The anxiety at that reunion is legitimate. But the answer isn't less technology. It's technology people can touch, inspect, modify, and own. The tools exist. The question, as always, is whether we keep them open. We've covered a lot of ground today. Let's close things out with something delightful, a piece of computing history you can actually watch. Page 47 of the IBM System 360 Principles of Operation Manual has a footnote most people skip. It describes 3 access methods for file organization: sequential, indexed sequential, and direct. 3 options. That's it. And those 3 options quietly shaped how every database, every file system, every cloud storage layer you've ever touched thinks about where to put bytes. This training film, mark IBM Confidential, now freely available on YouTube, walks through file organization concepts with the kind of unhurried technical clarity that modern developer education has almost entirely abandoned. No animations, no engagement metrics, just precise diagrams and a narrator who trusts the audience to follow the logic. Pull this thread. The System 360 shipped in 1964. The file organization principles in this video predate Unix, predate the relational model, predate everything we think of as modern computing. And yet, indexed sequential access method, ISAM, is still the skeleton inside every B-tree index your database runs today. The direct access method described here is what we now call hashing. Sequential access is still how every logged structured merge tree works. We renamed things, we didn't replace them. The question nobody asks about the System 360 is this: what did we lose when these architectural decisions moved from published manuals and training films into proprietary black boxes? IBM documented everything, obsessively. The access methods were explained because customers needed to understand them to use them well. The machine respected its operators enough to show its work. 62 years later, the engineering is extraordinary. The craft deserves admiration on its own terms. And the fact that this film is now public, freely watchable, freely teachable, that's the correction. Knowledge wants to be shared. It just sometimes takes 6 decades to escape the watermark. This has been your daily tech feed for Hacker News for May 26, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voiced by Qwen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something worth sharing. We'll see you back here tomorrow.